Good morning, everyone, and welcome to today's webinar on solid simulation optimization. So, what exactly is optimization? So, this is a computational technique that is used to improve the performance, efficiency, and reliability of the designs through iterative analysis and refinement. So, before we start with the optimization process, we need to know some key concepts involved. So, the first and the important concept is that we need to have an existing study because so the way optimization works is it is using the initial results as the basis for improvement. Next, we have the design variables. So the design variables are the parameters that can be adjusted to optimize the performance of a design. These could include the dimensions, material properties, boundary conditions, or any geometric features. Then we have to define what exactly is the objective of this optimization process. This can be anything like minimizing the stress concentrations, maximizing the stiffness, reducing the weight, or minimizing the cost. Then you have to specify the constraints. So constraints here are going to be the limitations or the requirements that the optimization process has to satisfy. These could include factors like stress limits, displacement limits, some manufacturing constraints, or even the geometric constraints. Also, what exactly is happening is in the optimization algorithm, which is used to identify the optimal solution that is going to give you the results specified based upon the criteria you have specified for the optimization process. So now we have the understanding of all the key concepts so that we can go ahead and take a look at an example here. So here I'm going to hop into Solid Edge. So here what I have is a simple bracket part, and I've applied some loads and constraints and perform an initial analysis to save some time here. So if you take a closer look, I have applied load. So the load here that I've applied is a 10,000 Newton load on the top face of the bracket. Then I've applied a fixed constraint on the face right here, as you can see. And then I have also meshed the model. So like I said, to start with the optimization process, I need to run an initial analysis. So let's hit solve here. So this should solve the model. And once the model is ready, we can review the results, which we'll be using later on. So here we have received the high stress achieved here is 190 megapascal, but I'm more worried about the displacement. So displacement here for total translation, as you can see, is 0.0524 mm. So my goal here is to reduce this displacement and also focus on the mass. So let me go and hide all these things. So to start a new optimization process, I can come to the new optimization command here, which should open a new window. So the first thing that you have to define is the objective. So you come to define objective, and in here you can specify anything that you want. So say for example, now I want to reduce the mass. So the current mass here, as you can see, is 0.324 kg. Here I can define my objective type. I have three different options to minimize, maximize, or set a target value. So here let's use this objective type as target and use the value as 0.25 kg. Then hit next. So next is where we specify the limits. So for limits here, I'll be using the total translation that we saw, and in here I can specify the maximum and minimum limit that the optimizer is used to give me is allowed to range this displacement value from. So all the way I'm going to say anything greater than 0 and less than 0.3. Next step, I'm going to define all the model variables which are allowed to be changed. So here I can change the thickness of the model, and I can also change the height of the height to angle, right? So Once you select the two variables, you can just hit add here, which should populate all the values. Now here I can go to rule and specify the same we did with the design limits. I can specify the range. So in here I'm going to specify the thickness range from 10 to 15, and I'm going to specify the height to angle in between 8 to 12. So once I've specified that, I can go to the next one, where which is the control parameters, where I can specify the number of maximum iterations allowed. So I'm going to just use the default 20. This does not necessarily mean that the solver will run 20 iterations. If it gets convergence at, let's say, 7th or 8th iteration, it will just stop there. And now all I have to do is hit optimize and let the optimizer take care of all the solutions. So looks like the optimizer has done solving. So now we get two different options. We can view the plots or we can view the summary. So let's take a look at this one where we view the summary. So once you select view summary, it will open an Excel file here. So let me pull that up real quick. And this is what that Excel file looks like, which specifies all the parameters that were defined, that the current value was 0.324 and the target value that is specified was 0.25. And these are the number of iterations. Like I said, if the convergence is achieved at any iteration, the optimizer will stop solving. Here, my mass value initially in the first iteration was 0.324. And at the fifth iteration, we see conversions at fourth and fifth iteration here to 0.253 kg. So this is how the optimizer solves and gives you the values. So the variable that was changed was from 15, the optimizer changed that to 10, and the height to angle variable from 10 was changed to 9.079. You can also take a look at the graph here of mass in kg versus the number of iterations. So this is how we can use the optimizer summary to view the results. The other way to view the results is if you come to the edge bar for simulation, you can expand each and every iteration in the results and see the plots. So for the first iteration, we had a total translation displacement of 0.0524, which is going to be the same as the initial value. And if you come at, let's say, fifth iteration, my displacement value came to 0.073. So this is how you can view the plots and the summary once the optimization process is complete.